Hi guys, welcome back, and we are continuing with the problems on pair of straight lines, specifically talking about the angles between a pair of straight lines. And I want to take, I think, two more simple problems, and then I will do harder problems which are more like subjective problems. But anyway, so let's start with the first question. Alright, we have to figure out the angle between the pair of straight lines which are given by, so this involves trigonometric angles y square sine square theta and then minus xy sine square theta, and then we have plus x square 1 cos square theta minus 1. So this is the line and this is equal to 0. This is the equation of the pair of straight line, and we have to figure out the angle. So let's do that. First of all, I have to write the general equation, so it's going to be equal to ax square plus 2hxy plus by square is equal to 0. Hopefully you are already familiar with this by now. And then we have the angle which is given by theta is equal to the inverse tangent of 2 square root of h square minus ab divided by a plus b. So our job is to figure out what a, b and h is, right? So let's do that. Let's see. We have coefficients for each of the terms, so let's just compare these two equations. So we have, first of all, comparing the x square term, we have cos square theta minus 1 is equal to, so cos square theta minus 1 is equal to a, right? And then we can compare the y square term. So when we do that, we get b is equal to sine square theta, right? Okay, now we can also figure out what the xy term is, but you look at this question and you see something special. If we look at the denominator, we see it has a plus b, and let's figure out what a plus b is first. So if we do that, well, we get sine square theta plus cos square theta minus 1. Well, we know from basic trigonometry that sine square theta plus cos square theta is 1, and if we subtract 1 from 1, we are going to get 0. So what that basically means is that this is going to be 0, and therefore the angle theta is going to approach 90 degree. So we don't even need to calculate the uh, compare the coefficients of xy, because the denominator is 0, and what that means is that angle is approaching 90, or it's equal to 90 degree, you can say. So one thing to note here is that in these types of questions, you should first probably check the denominator if it's equal to 0, and if it's not, then you can just continue with your question. But if it is equal to 0, then you can stop there and you can just directly conclude the angle is 90 degree. So hopefully that makes sense, and I want to do one more question. Let's see if I have room here. Actually, let me change my screen. Okay, I have to figure out the angle between the pair of lines given by the equation x square. Let me move to the top. Sorry, x square plus 2xy plus, oh sorry, minus y square is equal to 0. So this is the equation of a pair of straight lines, and I have to figure out the angle between the pair of straight lines. So we can easily do that. We know the formula, theta is equal to inverse tangent of 2 square root of h square minus ab upon a plus b, and we can clearly see that. So first of all, let me write it down so it's easier for you to follow. I'm writing the general equation of a pair of straight lines ax square plus 2hxy plus by square is equal to 0. Just compare this equation with this equation. We get a is equal to 1, b is equal to minus 1, right? And then wait, so a is equal to 1. I think this question also has that same special thing involved in it. A is equal to 1 and we have b is equal to minus 1. So you see a plus b is equal to 0, and what that means is that theta is equal to 90 degree. We can stop our calculations. We don't need to calculate what h is because a plus b is equal to 0, and therefore we can say that theta is equal to 90 degree or theta is approaching 90 degree. So you saw in these two problems that it's, I think, a great idea to first check what the denominator is, because if it's equal to 0 you can actually save a lot of time. You don't have to do complicated computations of the numerator and so on. So thanks for watching this video, and in the next video I think I'll do more subjective kind of problems which are definitely harder than these types of questions. So thanks for watching.